Welcome again everyone, this is Yasser Al-Wasifi from Learn Dental series. In this episode we will continue to discuss the indirect metallic restoration and our example as cast gold restoration. Let me declare that I don't receive fees, compensation or royalties from the sales of any of the products shown or discussed. Also, I declare that this presentation has not been sponsored by any company, agency or organization and is only prepared for educational purposes. This presentation is copyright protected and could not be transmitted by any electronic or mechanical means without prior permission of the author. Today, in this episode, we will continue to recognize the principles of cavity preparation for indirect cast gold restoration and how to prepare compound or complex class 2 cavity preparation for cast gold restoration. In the first part, we already discussed the material review in terms of history, introduction, definitions, composition, and the classification of dental gold alloys, and what are their advantages and disadvantages, what are their indications and contraindications. In this episode, we will discuss part 2, which is related to the cavity preparation, including principles of cavity preparation, general features of prepared cavity for indirect gold restoration, class 2 cavity preparation for indirect gold restoration, and we will discuss in full details a case report for a case for indirect gold restoration. For cavity preparation, let us start with the principles of cavity preparation for indirect gold restorations. Okay. Principles of cavity preparation for all indirect metallic restorations and mostly all indirect restoration, including path of insertion, outline form, the bevel, stability, and retention. Otherwise, all are the same as stated by J.B. Black and modified by other researchers in cavity preparation for all restorative procedure. Let us start by the path of insertion. As being indirectly prepared material, you are in need to define a path that allows insertion and removal of both wax pattern and restoration in a definite path without distortion, especially wax pattern in one direction. Okay, this direction should be as good as possible in the same direction or opposing the occlusal forces. Okay, in order to provide cavity with maximum resistance and retention, because if the restoration tends to be displaced out the cavity, the occlusal loading force will reseat it in place again. Okay, that's why the cavity walls should be either parallel to each other and to the path of insertion, okay, or slightly diverge about 5 to 8 degrees from the long axis. Why 5 to 8? When you take 5 and when you increase this divergency up to 8 or sometimes to 10, the divergency of the wall is affected by the length of the cavity walls and dimensions of and the details of the cavity. Okay, whenever your cavity wall is long due to caries or due to extensions, whatever the cause why it is long and the cavity is deep, you are in need to increase the divergency, okay, and the taper of the wall to make sure that you have no undercuts and at the same time to relieve the stresses during seating of your inlay and to relieve the stresses during withdrawal of wax pattern to avoid its deformation. Okay, whenever also the details and dimensions of the cavity increased, you are in need to increase your taper to take the 8 degrees rather than the 5 degrees divergency from the long axis or from the path of insertion. Why? Increasing the details means that increasing the chance for undercuts. To make sure that your undercuts are or your cavity, prepared cavity, are free from undercuts, you need to increase this taper. Okay? In these cases, we will discuss in the coming slides how this affects the axial retention. Does this decrease when you increase the taper? Does this decrease the frictional wall retention or increase it? That we will discuss in the coming slides. Then what about the outline form? Okay, in general, the general rules of performing the outline form is not affected by the type of material. It is just a recommendation. Okay, then all carious lesion, this is obsolete. All carious lesion must be involved because already you are cutting or designing a cavity to manage a carious lesion. Okay, then all bits and fissures must be included. Although it is an old concept and now it depends on the oral hygiene of the patient, okay, but in our condition, all bits and fissures must be including. You should extend your margins for self-cleansable area. All of these are the same and applied with the same concept for either indirect metallic restorations or direct restorations, either metallic or non-metallic, okay? But in general, the final result, the outline form of indirect metallic restoration and of gold especially appears wider than that for direct metallic restorations like amalgam. Okay, why? Okay, did we need to increase this outline form or to widen it? No, actually, gold restoration as being a high strength material is not in need to a specific width or depth for cavity preparation to provide bulk resistance. The material could be finished into thin margins. You could use it in a very thin bulk, okay, without any danger from material fracture, okay, because it is not a brittle, it is a high strength property material. But in general, the cavity finally appears wider than that of amalgam. Why? Because the case, as we discussed before, is indicated for cast gold or indirect gold as being extensively damaged. Okay, that's why it is indicated for indirect metallic restoration, and that's why it's a wider cavity from the origin, from the start. Okay, it's a wider cavity. Okay, the needed extension for prevention is slightly more than that for amalgam because of lack of adaptation. You need to increase the cavity to make sure, or to widen the outline form, to make sure that all your margins are in a self-cleansable area, because the material or this type of restoration lack adaptation. The wall divergency results in the outer diameter seems to be wider than that for amalgam. Also, after you are diverging the walls, you added extra beveling of the enamel margin to allow burnishing or to get room for burnishing the gold to protect the cement line. This also let the cavity appears wider, okay? And this is to drive the burnished gold away from the stress bearing area. You need to widen the cavity because your bevel, which will be covered by a very thin layer of gold, this very thin layer of gold is not able to fracture but able to bending if it comes under a cusp tip or it comes under a stress bearing area. That's why you need to widen the cavity slightly to drive this burnished gold away from stress bearing area and away from bending that will open the margin and let the cement exposed to outer environment and liable to solubility. Other than this, the intermediately used materials, including impression, including wax, may in need to widen the cavity to have a bulk strength to be withdrawn from the cavity without damage. If you have a very thin or a very narrow cavity portion, okay, for gold it's okay, but the problem is, what about the tear strength of your impression material? It may fragment from this very thin part, so you are in need to widen it slightly. The same for wax pattern, it may undergo fracture or breakage, okay, or distortion. That's why in general the outline form seems to be wider than that for direct restorations. Okay, then especially for indirect metallic restorations, there is a bevel. You should supply your margins, cavo surface margin, with bevel. Why? Because when you are diverging your cavity, that means that the cavity walls will not be in the same direction of enamel rods, and you will have a weaker enamel. So you are in need, number one, to remove the weak enamel and to protect the cavo surface margin by covering it by gold. Okay, that's why, okay, you need to create room to burnish, okay, metal, okay, to produce burnishable metal margin. Also, this circumferential bevel along the margin creates circumferential retention that increases the surface area that is subjected to friction between the fitting surface of your inlay and the tooth structure. Okay. Also, it is considered as flexible extension of the cavity margins to area self-cleansable, especially at the triangular fossa and the marginal ridge. Let us discuss this diagram. Okay, when you are laterally extend the cutting of your cavity, or you are doing a lateral extension of the cavity, okay, you are in need to be in a self-cleansable area. Okay, when you extending your cutting with your tapered fissure burr, okay, and you are going to diverge the walls, then you are extra thinning this margin, which becomes weaker and weaker. That's why let it in its place, okay, let it thick enough in expense of there is no caries, and when you bevel it like the photo to the right, okay, the most right one, then your cavity margin will extend at the end of your bevel. Then it is considered as flexible extension. Okay, we are trying to make some illusion, okay, or we are trying to extend the margin without driving the whole wall to the side, okay, and without weakening the structure. That's why when you are trying to get your margins at self-cleansable area, okay, it is wrong to do it by extending your lateral extension much more to this self-cleansable area, because your cavity wall is already seems to overcut the marginal ridge, okay, due to its divergency. Then the right thing is to bevel it or to provide bevel. That's why cavities prepared to receive indirect gold or indirect metallic restoration will have the following bevels: two mandatory ones, and one is considered as optional according to your cavity design. Is it a compound or a simple cavity? Okay, for simple cavities or for all cavities for indirect restoration, you should have a full bevel. What is meant by full bevel? Full bevel means that this divergency of the walls starting from the pulpal floor, okay, up to the cavo surface angle, this taper with a slight divergency from the long axis or from the bus of insertion by 5 to 8 degrees is considered as full bevel. This is number one, and this is mandatory because you should have a path of insertion by diverging the wall relation. Okay, this one. The second one is either a short or a long bevel in case of indirect metallic restoration. Okay, short or long bevel, it will be discussed later according to the degree of friability and the needed retention, okay, for this cavity. Okay, and this is a mandatory one to create a room for burnishing and to flexibly extend the cavity to area self-cleansable and blah blah blah, as we discussed a few seconds ago. And an optional one according to the type of preparation at the gingival floor, if it is a compound cavity, which is called reverse gingival bevel, that will provide both stability and retention for gold indirect metallic restoration, especially cast gold restoration. Okay, then comes a new terminology which is called stability. What is meant by stability? Your restoration is indirectly processed, okay, and already due to application of separating medium and due to dimensional changes which tends to be shrinkage of all used materials, okay, except the investment that we hope it compensate for this shrinkage, okay, then your restoration comes not fitting, it's just fitting with a slight friction, okay, not maximum friction, because if you have a maximum friction, either you will split the cusps or split the tooth, okay, or the restoration will not be properly seated, okay. That's why there is a great liability to restoration to rock in place, okay, to be unstable, especially the walls eye diverge. No converging walls, okay, relation that will prevent this rocking and provide stability. That's why you need what is called stability. Stability means the restoration, okay, will not be detached or dislodged outside the cavity, okay, but it could be displaced. It could rock in place. That's called stability, okay. It will not be absolutely dislodged, but it could rock unstable. This rocking by time will break the cement line, leads to its fragmentation, and may affect at the same time, okay, the strength of your cusps, okay, that may add extra strength to your cusps that may lead to its fragmentation. That's why, okay, you should have stability in a form of flat and smooth bulbar floor, sharp internal line angles, sharp axiobulbar line angle, path of insertion and removal opposite to the occlusal forces, loading force, to use it to stabilize the material, proximal axial grooves, and reverse gingival bevel. This is the sharp internal line angles, okay, and this is the flat smooth bulbar floor. This is the sharp axiobulbar line angle, okay, and this is the proximal axial grooves. Let us discuss in details the reverse gingival bevel. When we look at this gingival floor, okay, comparing the left to the right, the left one is the normal slanting of the gingival floor enamel to be in direction with enamel rods, okay. This is not considered as a bevel. This is just finishing of enamel wall to be in direction of enamel rods. Our enamel rods at this area is slanting to outside. That's why, okay, we prepare it with gingival marginal trimmer, okay, to create the proper direction and the proper finishing of enamel wall. The restoration, either it is direct or indirect, it is not related to the technique, it is related to the direction of enamel rods, okay. And this form is applied to all types of restoration. Otherwise, this very thin triangle could fragment, leading to recurrent caries, and this is the most commonly cause or explanation of recurrent caries under class 2, okay, either it is amalgam, composite, gold, whatever, which it is, okay. But for indirect metallic restoration, with a sharp internal line angles, especially axiobulbar one, but the walls are diverge, okay. When the force is applied, okay, it will analyze due to this slope to outside to produce again, okay, it will analyze to produce a component of force, okay, which is directed to outside, okay. This outside direction tends to rotate your cast restoration around the axiobulbar line angle, okay. In case of cast gold restoration, due to its high strength properties, okay, we made a reversible one in dentine. You could note that when a reversible one created, which is called reverse gingival bevel, it elongates your axial wall, and by its design it provides lateral retention. It prevents lateral displacement, but at the same time it elongates the axial wall. Okay, remember this. Okay, when force is applied, it will be analyzed into two opposing directions and cancelling each other, and the restoration will be stabilized in place and will not tend to rock. Okay, did we need to do this with direct metallic restorations as amalgam? Are we in need to do this with direct composite restorations? Are we in need to do this with indirect static restorations? No, it is only limited to gold because of its high strength properties, okay, its ductility, okay, its ability to be finished into thin margins. What happens if we add this design to class 2 for amalgam? For amalgam is a brittle material. Then you will add an extra stress concentration by this line angle created at the center of the reverse gingival bevel. At the same time, researchers proves that okay, mercury, due to its high density, okay, when you are condensing amalgam at this area, mercury will not be attracted to the surface, and the mercury rich layer will not be attracted to the surface. It will go down at this corner, accumulated at this corner, okay. And at the same time you have two thin margins of amalgam less than 2 millimeters. Then you are adding a stress bearing or a stress concentration sharp line angle at this area, which will split your amalgam into two halves longitudinally, okay, because amalgam at this area is weak because of concentration of mercury rich layer, or concentration of mercury will be concentrated and accumulated in this place, and at the same time there is a reduced thickness of amalgam. This is for amalgam. For composite, okay, it's the same. Brittle material, have no thickness, but at this area you will not have a pooling of mercury, you will have a pooling of bonding agent or of resin, which also considered as weak point. Okay, for ceramics it's the same. It's a brittle material, okay, that may be chipped at these thin margins. That's why this is limited only for indirect metallic restorations, especially gold. Okay, then comes the retention. Never forget that we mentioned that there is a problem with axial retention, especially. Okay, when we consider the retention, we don't have any problem with lateral retention. Lateral retention, okay, against displacement, you have a proximal dovetail. Okay, here it is mandatory, especially in premolars, and considered as extension for retention. Okay, but for amalgam you are not in need for it. Okay, then if it is not clear, and if you don't have a buccolingually wide triangular fossa, and your outline form, okay, when you apply the principles to include all bits and fissures and fossae, okay, will not give you this shape, you should increase the extension buccolingually at the marginal area, okay, other marginal area, to cut a marginal proximal dovetail. Okay, this is one. Two, you have proximal axial grooves. Okay, these proximal axial grooves are cut along axiobuccal and axiolingual line angles, okay, starting from the gingival floor up to the cavo surface angle. In case of amalgam, it's only up to the pulpal floor, okay, and it should be without any undercuts. Okay, proximal axial grooves provides lateral retention mainly, okay, but it provides also stability to prevent restoration rocking, okay, and After a while, I will mention to you that it will provide also axial retention. Reverse gingival bevel, we just discussed it. It adds also lateral retention by its design and will add at the same time a little bit friction by increasing the length of the wall. Okay? Then, axial retention mainly depends on and could be gained 99% by the friction between the nearly parallel cavity walls, and let us say from 1 to 5% by the cement locks that seal the gap. Okay, but don't depend on mainly on the cement to retain your restoration. The cement mainly is to seal the gap and improve the adaptation. That's it. That's it. Okay, but not to that extent a powerful retentive feature in axial retention or even in lateral retention. Okay, your friction between walls is affected by 4 factors. Number 1, the relation between walls considering the degree of divergency. Okay, depth of the cavity regarding that will affect the length of the wall. Bulbal floor line angles, is it sharp or rounded, and the type of bevel. All of these factors are in generally directed you toward the length of walls in parallel or nearly parallel relations that creates frictional force retention or frictional retention. Let us discuss them as the relation between walls. The more the diverge relation, the less will be parallelism and the less will be the frictional wall retention. That's why we always say that slightly diverge 5 to 8 degrees, or it is better to say it's in a near parallel relation. If it could be absolutely parallel, okay, is it better? Theoretically, it is better. But clinically and actually, absolutely parallel cavity walls relation, okay, yes, it will provide maximum axial retention, but it is not recommended because, number 1, it is impossible for a hand of operator to create all the walls absolutely parallel to each other. Surely there will be micro undercuts. That's why it is absolutely difficult. It is better to be slightly diverged to ensure that you have no undercut. If you prepare your cavity, and if we propose that it is possible, okay, the restoration will not be seated in place because the total friction of exactly parallel walls, okay, will lead to one of two things. Either your restoration will not be properly seated because there will be a back pressure, or when you try to force it to be properly seated to reach the bulbal floor, it may split your cusps or fracture your cavity preparation or fragment of it. At the same time, if you prepare it in absolutely parallel, that means that, okay, you have one solution to reduce this frictional forces that may not seat the restoration or may fragment your tooth. It is by adding multi-coats and creating a larger gap of your restoration between the fitting surface of restoration and the cavity walls to relieve this pressure. Okay, you may in need to remove from the fitting surface, okay, and violate the relation between the fitting surface and the tooth structure. Okay, that's why, okay, actually absolute parallelism is not practical and is not reliable. Okay, you should know that the greater dimensions and the details of the prepared cavity, okay, will be in need for more wall divergency to avoid any resultant undercuts. What about the friction? The total dimensions of the cavity or the total surface area will provide a total satisfactory friction. Okay? That's why sometimes when comparing class 2 for premolars and molars, okay, you may need to increase your divergency in molars because of increased details and dimensions of the prepared cavity rather than the single fissure of occlusal preparation of the premolar. Then comes factor number 2, the depth of the cavity. The greater the depth of the cavity, the more long will be the wall, okay, and the more friction produced between the walls. But this does not mean you are in need to violate the routine cavity depths, okay, just to gain friction. You didn't need to increase your routine cavity depths, which is 0.5 millimeter as maximum beyond your dentino-enamel junction, unless you have a caries. Okay, 0.5 millimeter beyond the dentino-enamel junction plus 1.5 approximately that of enamel thickness. Okay, total of 2 millimeters is quite enough when you considered the other details of the cavity, the dimensions of the cavity, and the degree of divergency, okay, of your cavity. Then comes the bulbal floor line angles. Bulbal floor with rounded line angles, okay, provides you lesser friction than that with sharp line angles, because sharpness of internal line angles, okay, takes that curve into consideration and adds it to the length of the wall. This curvature of roundation will shorten the length of the walls in parallel or slightly diverged relation. Remember that this could not be produced by bare, okay, angle former is specially designed to sharpen and identify the internal line angles in cavities prepared either to receive direct or indirect cold restoration. And finally, the type of bevel. Okay, the bevel, as we mentioned before, okay, you should mandatorily have a full bevel, which is the divergency. The full bevel started from the bulbal floor up to the cavo surface angle. This is translated into divergency. But to protect the enamel margin, okay, you have another bevel. Either it is the full thickness of enamel, including the full thickness of enamel, then it is called long bevel of cavo surface angle, or a part of the cavo surface angle, which is short bevel. Okay, theoretically, long bevel surely provide a satisfactory room to burnish gold that will provide maximum protection of enamel margin and maximum protection of cement line. At the same time, the base of your burnished part will be thick and will not be subjected to bending. Okay, at the same time, it provides maximum flexible extension, okay, to area self-cleansable. Okay, but at the same time, it will shorten the length of your wall in parallel relation. In controversy to that, short bevel will leave you with sufficient length of the wall, but at the same time with questionable protection of your enamel margin. Okay, that's why intelligent or smart operator should compromise between the cavity depth and the type of bevel. If your cavity is a deep one due to caries, then you are still have a sufficient wall length, okay, that allows you to go for long bevel and you are satisfied by your length. Okay, in shallow areas, okay, you could change from long bevel to short bevel, and also it is also will provide, okay, you with sufficient length of the walls. Finally, proximal axial grooves. and reverse gingival bevels provides both axial as well as lateral retention, also in addition to stability. They are mainly designed to add lateral retention, but reverse gingival bevel, as we discussed in the schematic diagrams, adds length to the axial wall, which provides more friction. The same for proximal axial grooves. Proximal axial grooves, by its cutting design, inexpensive of buccal and lingual rather than axial, okay, it provides lateral extensions that engage your gold, okay, and prevents its lateral displacement. But at the same time, by grooving this line angle, you add much more surface area that will provide also frictional wall retention. In general, the general features of prepared cavity for indirect gold restorations or indirect metallic restoration will be: number one, the external dimensions of the preparation of wider than that of the internal, okay, to allow withdrawal of the wax pattern and insertion of the inlay without any distortion, okay, of the wax pattern, and at the same time easy insertion and seating with minimal friction of your inlay. Parallelism of axial walls, okay, for frictional retention, okay, and to prevent axial displacement, so that the walls are prepared with a slight divergence from 5 up to 8 degrees. Cavo surface bevel, either short or long, full or counter for weak cusps, okay, to provide maximum protection of enamel margin, protect the cement line at the same time, that will provide you with a room for burnishing of gold, okay. The cavity is more extended buccolingual outline, okay, because of the divergence of the wall and the cavo surface bevel. The buccal and lingual wall of proximal cavities should be more flared and extended into the corresponding embrasure to be surely in a self-cleansable area. Definite sharp internal line angles to guide your single pass of insertion and at the same time resist displacement or rocking inside the cavity and provide stability. And finally, extension for retention is an alternative to augment the retentive features of the preparation, since the gold inlay is a one-piece strong restoration. And this extension for retention, as we discussed in case of premolars, we need to widen the area or the dovetail area in the other proximal surface. Finally, those are my textbook, okay, if you are in need for further reading or much more wider knowledge in this field. And feel free and don't hesitate to ask, as your questions are always welcomed. You could ask me by commenting on this video and I will reply to you as soon as possible. Finally, thank you for assigning this time to listen to me, okay, and please don't forget to subscribe to this channel and to my channel and activate the notification to get all the new updates of this channel and my new episodes. Thank you so much. ياسر الوصيفي.